So we have already talked about what fractions are, what they look like, different types of fractions, how to simplify fractions. I want to spend a few minutes discussing just different properties of fractions, special situations regarding fractions. And I want to define a new term, and this is really going to be our first really official algebraic definition. A lot of the things you learn in algebra are used later to define certain terms and ideas. And so I'm going to define a new term here, and it is rational. A rational number. Okay? A rational number is any number that can be written as A over B, where A and B are real numbers and B does not equal 0. Pause, stare at that for a second. Read it, reread it, try to make sense of it. I'll describe some things. So, rational number, any number that can be written as A over B. So what do we see here? Right? We see, that kind of looks like a fraction to me, right? That looks like a fraction. But then I say where A and B are real numbers. So we're not going to get into things that are not real numbers in this class. Those would be imaginary numbers. Maybe you've encountered those in a previous math class. For our case, A and B are real numbers, and those are just any numbers that you're aware of, that you know. But then there's this other little stipulation that says B cannot be 0. And can you think of why that would be? I'm going to leave it there and come back to it in a minute. So essentially, when you hear the word rational when it comes to algebra or math, rational numbers are fractions, or they're any number that can be written as a fraction. We do have certain types of numbers called irrational numbers, and there's no way to actually write them as a fraction. You may be familiar with some of them. Pi. The number pi is an irrational number. You may know of it as a decimal, 3.14, but it really has decimals that come after that. They just go on with no pattern, no repeating or anything. And so those are irrational numbers. All the other numbers, the rational ones, there's some way to write them as a fraction. So what are some other things that we need to know about fractions? I'm going to put 5 fractions up here. And what I want you to do is just stare at them for a second. That's always what I tell you to do. So here are the 5 fractions. And there's the first one. There's the second one. Here's the third one. Here's the fourth one. And here's the fifth one. And my question to you now, this is so crucial for so many things moving forward, is are any of these equal to each other? If so, which ones? Are different ones equal to each other? Are they all equal? Are none of them equal? I want you to just pause and think about that and take a guess. I'm going to keep going. So, you have to think back now to our conversations involving integers and what happens when you're dividing by integers, because a fraction really means divide. -2 on top, 3 on bottom really means -2 divided by 3. And how many negatives do you see there? I see 1 negative. I'm going to jump over to this one, this third one. 2 on top, -3 on bottom. Another way to think about that is 2 divided by -3. How many negatives do you see? 1. Well, I'm going back to this one. Negative out in front, 2 over 3. This is saying we've got the fraction 2/3, whatever that value is, and it's negative. Don't think about a fraction as two separate numbers. As I said in the last video, what matters is the relationship between the two numbers. 2 and 3, how do they compare to each other? It really has a single value, and in this case, that value is negative. So this one, and this one all have one negative, right? These are all equal to each other. These are all representing the same value. I would say this is, these two are probably the more ideal common ways that you're going to see them. This one, we generally don't like to leave negatives on the bottom. It's not like it's a bad number or something. There couldn't be such a thing. But we'd still generally like the negative on the bottom. If you have it, sometimes you'll bring it out to the front. Sometimes you'll put it up top. Sometimes it doesn't matter. But all of them have one negative, and so these are all equal. Many times, people will confuse this one right here and think it's that, thinking that a negative out front means that both the top and the bottom, both the numerator and denominator, are equal. That is not true. Let me even erase those lines. This one means -2 divided by -3. And a negative divided by a negative is a positive, right? These negatives actually can cancel each other out. These two fractions are actually equal. These have a positive value, while these three all have a negative value. And lastly, the last thing, I'm going to put 3 different fractions up here. We're going to examine them. So I'm going to use a variable. Again, we're kind of like looking at algebraic definition here. A over 1, 0 over A, and A over 0. So take a minute, examine those, see if you can think about what those might mean, or how you might simplify them. So, A over 1 means there's some number, I don't know what it is, but I'm putting it over 1. It could be 7 over 1, 3 over 1, 5 over 1. Anytime you have a number over 1, that means that number divided by 1, and it's always going to be equal to whatever that number is. 7 over 1 equals 7. 3 over 1 equals 3. 5 over 1 equals 5. So when we simplify fractions, that's another thing that we always like to do. 0 over A. We actually talked about this before. We didn't write it in this notation. 0 over 5. 0 over 10. 0 over -99. 0 on top and a number on the bottom. Those are always going to be equal to 0. We can take the number 0 and divide it by something. It ends up to be 0. A over 0. 7 over 0, 19 over 0, -352 over 0. Oh, what was the deal with this? You can never divide by 0. You can never have 0 on the bottom of a fraction. If you try to do it on a calculator, it gives you an error message. We say it doesn't even equal something. We call it, there's a special word for it, pause and think of it, undefined. Any number over 0 is undefined.